Good morning and greetings to everyone joining. Investment and Development Agency of Latvia is pleased to invite you to take part at the third Mechanical Engineering and Metalworking Business Forum of Latvia, including outstanding presentations by renowned local and foreign speakers from the industry. The forum will provide excellent opportunity to exchange experience and discuss new global trends, the successful development in mechanical engineering, explore new opportunities and competitive advantages to establish business in Latvia. My name is Kristaps Talbergs and I'm going to be the host for the forum. Before we continue, let's take a brief moment actually to discuss, and I will introduce to some technical details. First, about the live stream and language options. Well, the whole event will be held in English with the translation into Latvian. You can watch this forum live stream on multiple platforms and enjoy it either in English or in Latvian. First option is Investment and Development Agency's homepage. That is lia.gov.lv. There, on the live stream corner, you have an option to pick a language you prefer, English or Latvian. Second option, I welcome everyone watching via Facebook at the LIA Facebook feed. There are two simultaneous live streams available for you. One is in English, the second one is in Latvian. Pick accordingly. And the third option is for our registered forum participants via Zoom. Make sure that you have an updated Zoom application installed on your computer. If so, then on the bottom bar you have an interpretation icon with a small globus on it. And click it on it and voila, you have two language options again available for you. Multiple language options are available only on Zoom application and unfortunately is not available on web browsers. Also, we want to encourage you to register for the forum, as the registered participants watching the stream on Zoom can see the Slido link and the ID number at the top right corner of your screen. Use that Slido link to ask questions during our panel discussions or to our guest speakers. The Investment and Development Agency of Latvia is local and international at the same time. A network of foreign representatives and cooperation set of connections with the other institution in Latvia and abroad bring LIA close to its customers and links them to the major markets, business partners and locations. LIA assists international companies to establish and expand in Latvia. It also provides trade advice, support and business opportunities to Latvian exporters. I'm honored to welcome right now Director of Investment and Development Agency of Latvia, Mr. Kaspars Rožkalns, to officially open the third Mechanical Engineering and Metalworking Business Forum here in Riga. Welcome, Kaspars. We can hear you and see you loud and clear. Welcome.
Awesome. Thank you, Kristaps, for great opening lines. Well, from LIA, or Investment and Development Agency of Latvia, first of all, I would like to say thanks for the big team that did this forum online, that it is possible that we are here, and I know that everybody is already exhausted from all the Zoom online, whatever events, and we are waiting for the vaccine, and as we can see, the airline stock shares are going up, so the world is expecting 2021 to be back more to the normal than 2020. Obviously, I am very pleased to see this big crowd of metal working guys, of mechanical engineering guys from a very international crowd joining today, as we have more than 100 participants from 20 countries, 20 plus countries actually. And this is probably, again, one of the pluses from the COVID-19, because yes, realistically, it was way more harder to travel internationally, via airplane, staying two days, 3 days, etc. You have to plan the schedule and so on and so on. However, now we can meet each other online quite easily. Let me get just a couple of points across about the metalworking and mechanical engineering industry in Latvia. So the first of all, it is definitely one of part of backbone of Latvian economy, because it's the second largest sector and very export-oriented sector. It's exports more than 80% of the oil production goes into foreign markets. If we look at springtime, COVID-19 came to Europe, and all the demand went really steep down. Also, the mechanical engineering and metalworking sector was struggling. However, the bump in March was a little bit less than, let's say, other industries, because obviously the contracts had to be filled out, and as the Latvia feels the part of tier 3 or tier 4 companies that produce some of the parts to the biggest companies, that we didn't felt this drop that steep. And then we recovered. Yes, we took a lot of bumps during that road, but during the September, the Latvian exports overall showed the biggest volume in production, in product exports overall ever in history. Therefore, COVID or no COVID, we can see that the Latvians can overcome these obstacles. We can work together. We are very connected. We are ready to for the challenges, and we are ready to innovate. And I really hope that this is, let's say, one of the discussion parts will be: is this an opportunity for production chains, and this is an opportunity for Latvia to bump ourselves up in this production chains? And for the short term, definitely we can move in the market that somebody exit, let's say player exited from the market, and we can move up in that market, but it's swimming in the red ocean. What the investment and development agency is promoting and asking for the industry and asking for these discussions. So the real companies, the metalworking companies, the mechanical engineering companies, first of all, would see the Industry 4.0 as the benefit, as it is, and maybe even to start to see what's beyond the 4.0. And this is our, let's say, task to push the companies to the path of innovation, because either we can compete on the price, or we can compete on the product and quality of the product. The quality of the product on the Western European standards is very high. So when we reach with the same tools, the same quality, we'll definitely reach the same price. So we have to innovate. We have to come up with new solutions, with the new approaches. And this is something where our agency is definitely part. We're really happy that the international players are here today to talk on the panels, to talk also on B2B events, to see the first KPI for us is definitely the business, what can happen in closest months, that you two business guys meet virtually and agree on a deal. And that's definitely one big part of our KPIs. But definitely on the other hand, the bigger KPIs is if the Western players and the local players see that the path to bigger growth, the joint growth, to compete together for the bigger international markets, then we have different kind of innovation programs and grant programs to support this path, to support the Green Deal path, to support the path of innovation. So I'm really happy for this forum. I hope that we'll be able, and by we I mean everybody who is joining today, to reach the short-term goal of business and reach also to a little bit longer term goal of change of the mindset of going to the innovation path and do not be afraid from the words Industry 4.0 or 5G or whatever else is there, robotics, etc., because it's going to happen either way, and it's better to lead the battle, not to fall behind. Thank you very much. That's it from me.
Thank you, Mr. Kaspars Rožkalns, for opening words. Thank you very much. Our dear Minister for Economics of the Republic of Latvia, Jānis Vitenbergs, was planned to be with us, but unfortunately the cabinet meeting is still in a process, and they have right now the very issue of COVID-19, new data coming in, and probably he's just busy taking those issues forward. We wish him good luck, and unfortunately he can't be with us this morning. So why choose Latvia? Since the last decades, mechanical engineering and metalworking has become one of the most prominent manufacturing companies in high export-oriented sectors in Latvia, as we heard before from Mr. Rožkalns. The mechanical engineering and metalworking industries have historically been one of the leading industries sectors in Latvia. And now I would like to invite Chairman of the Advisory Board of Association of Mechanical Engineering and Metalworking Industries of Latvia, MASOC, Mr. Vilnis Rantiņš, to say a few opening words. We welcome you. We hear you loud and clear and see you. Welcome. You have to unmute yourself, Mr. Rantiņš, please. Click on the microphone that is still maybe red. Now maybe we will fix it. It's all right. Yes, yes, loud and clear. Welcome.
Good morning, dear colleagues, ladies and gentlemen. I congratulate you with participation in the third Mechanical Engineering and Metalworking Business Forum. I hope that during the forum you will be able to find for yourself new cooperation partners, as well as you will learn many new things, because in the forum there are more than many participants from more than 20 countries. That means that we have wide opportunities for potential markets to expand in them. And I have to say that at the moment, this industry, despite all the difficulties, is developing very successfully. Our products are being exported to more than 113 countries all around the world, which proves our capacity, as well as the amounts of production and export have stayed in the level of last year, meaning that the trends or the trend shows room for development. And I believe that this forum will give yet another signal for us to continue our development, not only for Latvian companies or from companies of our industry, but we will gain also valuable information as to other industry members from all around the world. So I would like yet again to congratulate you with this event, and we hope for cooperation. Thank you, Mr. Rantiņš.
And what a great topic to start the forum. Our first keynote topic is Industry 4.0, the big picture. We welcome Vice President and Head of External Cooperation at Siemens Corporate Technology, Professor Dr. Dieter Wegener. Welcome.
Good morning, ladies and gentlemen, and good morning Christoph Stalbergs, and thank you very much for the kind welcome. Can you see my presentation?
No, unfortunately, we cannot see it. Could you share your screen then?
I do it, yeah.
It's all right. This is all new for everyone, yeah. So it's.
Yeah, we have tested it, but that is okay.
All right, it's slowly coming up. Yeah, we can see the first page, and probably you should. Yes, yes, we can see it clearly. You can continue.
Okay, so welcome again, ladies and gentlemen. I have the honor to talk today to you on the topic Industry 4.0, the big picture. And I do it in my role as speaker of the Z4E management team Industry 4.0. And what is Z4E? That is the German Association for all electric and electronic manufacturers. These are 1,600 companies, small and big companies. So my presentation, I divided in 4 parts. And I start with digitalization of economy. You know that the digitalization of economy is leading to a connected world. You see here the smart home and smart building application field, all the people in the healthcare arena, smart mobility, smart grid, and last but not least, Industry 4.0, meaning all factories and process plants connected in a production network. When you look this more from an analytical viewpoint, you have those 5 application scenarios beside. And here it's very important to understand that digitalization of economy has 2 parts. One part is that you take the analogous economy, which is well known to you because we are doing this since decades. That means an analogous value add, meaning, for example, taking a sheet of metal, having a machine tool, making out of this sheet of metal a product which you distribute to your customer with a logistic partner. And this is where you own analogous euros. And beside of that, you have second, the new business through the digital, through smart services, and this we call digital economy, which is based on the data evaluation. And what does it mean? I show you here. You see here below the so-called OT devices, operational technology devices. So machines, trains, windmills, gearboxes, robots, and all equipment which are machines and apparatus. And these are called operational technology. And then you have the IT, the information technology. And this is spread up in an architecture of 3 layers. The infrastructure as a service layer, these clouds where you have data centers where you store the data. Then you have the platform as a service layer where you have the operating systems, making the Internet of Things platforms available to take the data from the OT devices and evaluate them, making a digital value add. Means that you take the big data from here and you analyze them with apps here in the software as a service layer. These are apps like on your smartphone, but here in the industrial arena. And with these apps, you analyze the data coming from the OT devices and make a digital value add. And the difference to the analogous world is that you create with the software app a smart data as the output. And this smart data will be distributed with the logistic partner called Internet as a smart service to the customer base. The difference of the logistic partner Internet to the analogous world is that this is working with speed of light and that is for free. And that is a big reason, that is the reason that you have a disruptive behavior of the digital economy. And that is very important to understand, and that's very important to take care on. Now I want to share with you what our Industry 4.0 is in specific. For this, we have created a concept which belongs to 3 dimensions. The first dimension is that you digitalize the value add. The analogous value add you make out of a factory, a smart factory. You make out of a plant, a smart plant. The same for the products. You make of a product, if you digitalize it, a smart product. And last but not least, you create smart services by evaluating the data coming from the smart factories and the smart products, as I mentioned before. And now I want to give you examples. First, for the smart product, you see here on the right-hand side a machine tool of a German manufacturer. And on the left-hand side, you see the digital twin of this machine. The functionality of this digital twin is, with the use of simulation tools, the same as you do it on the right machine, on the real machine. The worker has the advantage that he can prepare the job on the machine, his next job on the machine. Beside of the machine is still running, is still productive, and he can work on his laptop anywhere in his home office or at a different location, far away from the machine. He can prepare the next job on the machine. The functionality is the same as you would do it on the machine, but you save time, and overall you increase the productivity by 10%, that is much, and you can use this concept of the digital twin to any purpose in your factory. Now I want to come to the smart factory, and I want to explain what is it. A smart factory, for this I take first a factory, a small factory, which you can see here. I make it a little bit bigger. You have a classical assembly line. You have a feeding station where you get bottles in. Then you have a station 1 where you put a white and red hat on it. And you have a station 2 where you put a blue and a red hat on, and then you get it out in the sorting station as an output. And the transition belt is transporting the bottles through this equipment. And you have sensors equipped to have information for the automation equipment. And what is the automation equipment? The automation equipment is such here in a cupboard. You have here, in this case, a Siemens equipment, a SIMATIC S7 1500, which is the control system for the whole setup. And you have some other boxes for driving the electrical drives and the sensors and all those things. And how it looks like. Now, when you want to make this factory smart, you have to digitalize the value add. And there's a whole working stream. And by this, you take first, you have to do 3 parts. First, you have to introduce a CAD software for design. And that means with that, you can include also a simulation tool, which is called Mechatronic Concept Designer. It's a simulation tool from Siemens, which enables you to simulate every physical behavior of your equipment in all cases. So you can simulate, for example, the bottles going around the conveyor belt, and with under the laws of physics. And that is the mechanical side. And now you come on the electrical side. You have also to simulate the automation system, the controller. And this you do also with the simulation software. It's called SIMIT in our brand name. And with that, you can optimize the factory. And you see here in the video the unoptimized system. And now you can optimize the design by taking care on the speed, taking care on the speeding and all those things. And here you see the feeding station here, and you see here the sorting station as the outcome. Now, that is the classical thing you have in all your factories. But now, what is the smart service, and how could you apply this to a conventional factory? And I want to show you this in an example. So you take the same equipment here, you take the same cupboard, but you put in here a MindConnect Nano box, which costs approximately 800 euros, is a high performance computing controller. And then you take software, a lot of software, because you need to analyze the time series coming from the sensors from your equipment, storing in this nanobox, and then these time sensors you put in a processor software, learner software, controller software, service-oriented architecture, user interface software. You have an operating planning software, and you have some databases to store the data coming from the time series. And this is working on a MindSphere operating system. MindSphere is the IoT platform system by Siemens. And with that, you can optimize the system without knowing the details of the system. The system you see here, in gray you see the original system, and in green you see the optimized system. And the optimized system will avoid all. The system will solve, with the help of artificial intelligence, find the global optimum on the system. And you see as a result that the optimized system is much faster, but with the difference that it is not putting the feeding station in the equidistant manner, but in a different manner. And this you can't find by a human being. You have to use artificial intelligence to find this global optimum. And I'm not sure whether you can see this on the video. Left, the unoptimized system, right, the optimized system. And here you can see the left-hand side is just running, and here the optimized system will be now ready, and this is still working. You see it's still working because of gems and unoptimized structure. And now you see the result. If you take the smart service to optimize your factory, then you can, in this case, increase your efficiency by 31.4%, just by using of software tools, a MindSphere platform system, and artificial intelligence for optimizing. And what do you have to invest? It is very simple. You have to take the same factory as you have, but you have to invest in this MindConnect nanobox on the hardware side, and you have to invest into software systems, cloud integrations, the simulation license, and you have to develop your app on this, which is very easy when you have experts in your team. And in this case, the break-even was lower than 1 year. That is very promising, and that is, I would recommend to you to apply smart services to your equipment in your factories and process plants. Now, I want to share the German initiative on Industry 4.0. In Z4E, we formed a team, the so-called Z4E management team, Industry 4.0. There are a lot of members, small and medium-sized enterprises, but also big companies as Siemens, and of course, research institutes and other partners. We have also a German political platform, Industry 4.0, you perhaps know, which is funded by the Ministry of Economy and the Ministry of Research. And we work together in a huge network in this community. The main task of Industry 4.0 is to bring the operational technology in the shop floor together with the IT, the information technology in the office floor, along the value chain, which is simplified here with the product development, production, and service. And the major challenge is to increase the interoperability along this value chain, and of course to raise up the interoperability between the shop floor and the office floor, between the OT and the IT. Now, what we do in the Z4E management team, we define an Industry 4.0 component, which is similar to the definition of a cyber-physical system. And this is a concept which works for all industries, from process industries over hybrid industries to discrete industries. And what is it? It is a normal product, an OT device, which is supplemented with an asset administration shell. Here's a blue shell. And this asset administration shell enables this Industry 4.0 component to have an Industry 4.0 compatible communication along this reference architecture model Industry 4.0, You can stick into the details if you go on the Platform Industry 4.0 homepage. There you have a lot of documentations and illustrations of this concept. And just to give you an idea, for the communication layer, there you see all those protocols. Perhaps you are familiar with TCP, IP, 4G, and in the future, time-sensitive network 5G, if it's mobile. And so the strategic approach in the Industry 4.0 initiative is, in a nutshell, on one page, to enable digital economy with the help of the definition of this Industry 4.0 component, introducing the I40 component with this asset administration shell on the right-hand side to connect OT devices with this IT board. And for this purpose, the German association Z4E and VDM formed an industry digital twin association as a user organization for Industry 4.0 on the 23rd of September of this year, so just brand new. And we are working also on a digital nameplate 4.0, which enable us to connect every OT device via an QR code to come to a valid standard, to come to a link on the internet, which is defined by this standard DIN spec 91406. For those who are interested in, please go into this link, there you get more details. Now I want to share a little bit in the last minutes what is Siemens is doing on Industry 4.0. You know this concept which I explained from the association viewpoint, and Siemens has this concept. It's the same, but just in a marketing illustration. We call it digital twin approach in the product design, in the production, and also in the performance. And it is very important that you need platforms, a platform for the engineering side, and also a platform for the data coming from the devices. And that is the MindSphere I explained already. And of course, this is all covered with application of cybersecurity means. And just to give you an idea, the virtual product, we make a design with digital twin. Here a car body, a framework of a fuselage, here a lever, and you can simulate everything what you like, also PCB boards and electronics and what you think about aerodynamic flow. You can simulate a wind tunnel, you can make honeycomb, you can do everything with simulation with our tools. And then you are going in the virtual production scene. So you think about how to make the production, but first in the computer. For this, you see here some applications in the shop floor with robots who are applying, or here in the pharmaceutical area, or in the assembling of an airplane fuselage or an airframe, or you go in the electronic arena, or here's a honeycomb where you produce it. So everything you can simulate also with software. And last, now you go in the real production. And in the real production, you know, this is what it looks like if you go in a factory or in a process plant. You see a lot of automation equipment, and this is enhanced with the MindSphere MindSphere IoT platform. So you can evaluate also the data coming from the production. And that is shown in the next slide, where you analyze all the production and product performance with MindSphere IoT platform. That is something you can improve your efficiency. With the use of analytic tools. So this is good, and MindSphere is not only Siemens, but it is a huge ecosystem containing a lot of partners worldwide. Here is just given a few partners. And now I want to finalize with two examples using artificial intelligence. One is in our factory at where you have a production line for welding the PCB boards, and the X-ray is necessary to control every part coming out of this line. And normally you we want to increase the volume of the production line, but there was X-ray was a bottleneck. So to avoid the investment of a new X-ray machine, we introduce artificial intelligence. So how do? We take out of this assembly line the data in real time. These are more than 40,000 production parameters for each time step. And then we put it in an edge device, going to the MindSphere platform, apply an artificial intelligence training software. This learns from the data, and the outcome was that we can avoid to invest a new X-ray machine to overcome the bottleneck by analyzing these data coming from the assembly line, and we could minimize the X-ray test by 30% by the same quality rate. The effect number is 99.9988%, and we save 500,000 euros by using this artificial intelligence. And the next example is coming from Hella, that is a customer of Siemens who is doing machine tools. And these machine tools, you know, perhaps the Hella machines, and they have this rack where you put the machine tools in, which is handled by a robot. And so the question is how to optimize the placing of the tools, because the farther away the tool, the longer the distance, the longer the way, the longer the time you need for the robot to bring it to the machine. So the optimization of this is not analytically solvable. So this is done by also applying application artificial intelligence on the MindSphere platform. And the outcome was that it was optimized as you can see here on the simulation by to put all those who are often used in the middle and all those who are not so often used in the corners, and that is very pragmatic, and we save by that 20% on productivity. And Hella is selling this as a new business model as a smart service to his customer base. So thank you very much for listening, and I'm now open for questions.
Thank you, Professor Dieter Wegener. Thank you very much. Right now, I'm checking that there are no questions. I believe your presentation was so fluent, so perfect. So everything was clear. Thank you for connecting with us.
Yeah, you're welcome. And I will share my presentation as a PDF file to the participants. I will send it to the team, and I'm happy to be here. Thank you.
Thank you very much.